Good day, everyone, and welcome to our lecture series in differential equations. For this video, I'll be sharing with you the first-order differential equation, particularly the variable-separable equation. Separation of variables. A first-order differential equation can be written in the form m as a function of x and y dx plus n as a function of x and y dy is equal to 0. If this particular equation can be written in the form a as a function of x alone dx plus b as a function of y alone dy is equal to 0, then the equation is said to be variable separable. The solution of this particular equation can be immediately obtained by integrating both sides of the equation. That is, the integral of a as a function of x dx plus the integral of b as a function of y dy is equal to the integral of 0. Let us have example number 1. Solve the differential equation 1 minus x times y prime is equal to y squared. So the thing in separation of variable is you have to inspect the terms of the given differential equation. Try to look term by term and determine what is not needed in that particular term. And then you divide it with those term or factors that are not needed in that particular term of the differential equation. So let us solve this particular differential equation. We are going to divide both sides of the equation. Sorry, the pen doesn't work. Okay. So we divide it both sides by the factors, the quantity 1 minus x and y squared. So dividing both sides, we now have dy over y squared is equal to dx over 1 minus x. Okay? And then, since we have separated the variable x from the variable y, we can now take the integral of both sides of the equation. So, the left side is the integral of dy over y squared, or that is simply the integral of y to the negative 2 dy, and this is the integral of dx over 1 minus x. So, taking the integral, the left side is equal to negative 1 over y is equal to, so if you let u to be 1 minus x, our du is negative dx, therefore this is negative ln of 1 minus x, and the constant of integration, since we have here ln, we may use plus ln of a constant. Okay? And then we just further simplify our results or our equation. We multiply both sides of the equation by negative 1. So you have here 1 over y is equal to ln of 1 minus x. You can use minus c or plus c. Since it is constant, let us take plus ln of c. And therefore, you have your result, 1 over y, by applying property of ln on the right side. That is ln of the product of c and 1 minus x. Or you may write your solution as y times ln of the quantity c times 1 minus x is equal to 1. And that is now the solution of the variable separable differential equation given. Now let us proceed to example number 2. For example number 2, solve the equation sin x sin y dx plus cosine x cosine y dy is equal to 0. So again, inspecting term by term, you identify what are not needed in the differential equation. So here we have dx, so we do not need here your sin y. And here we have dy, so we do not need here cosine x. So let us divide both sides of the equation by those terms not needed or those factor not needed in the terms. So we divide it by sine y and cosine x. And the resulting equation now is, let me write it here. So you have sine x over cosine x dx plus cosine y over sine y dy is equal to 0. So x and y now are separated, and therefore we can take the integral of all terms of the equation. So this is your tangent of x dx, and this is cotangent of y dy. You can write directly your solution to the integral of tangent and integral of cotangent. But if in case you can't recall what is the integral of tangent and cotangent, then you may use our conventional method of finding the integral. If you let u to be cosine x, our du is negative sine x dx. Therefore, negative sine x negative du is your sine x dx. So therefore, this is simply equal to negative ln of cosine of x. And for this one, if you let u to be sine y, then our du is cosine y dy. So the numerator is already your du. So the integral of du over u is ln of u, or ln of sine y, is equal to the integral of 0. We can use c, but since the left side of the equation contains ln, then you have ln of c. To further simplify our resulting equation. And then applying property of ln on the left side, this is ln of the quotient, since plus and then you have here minus, so ln of sine y over cosine of x is equal to ln of c. And then taking base e of both sides, you now have sine y over cosine of x is equal to c, or sine y is equal to c times cosine of x. Okay? Let us move to the next example. Solve the equation xy cubed dx plus e to the x squared dy is equal to 0. Again, inspecting the terms of the differential equation, what are not needed in each term. So for the first term, we do not need y cubed. And on the second term, since it is dy, we do not need here your e to the x squared. So what we are going to do to separate the variable x from the variable y is to divide it both sides by y cubed and e to the x squared. And the resulting equation after dividing is x e to the negative x squared dx plus y to the negative 3 dy is equal to 0. So the first term, x with dx. Second term, y with dy. So we can now integrate both sides of the equation. Okay? So how are we going to integrate the first term? If we let u to be equal to negative x squared, what is our du? This is negative 2x dx. But we only have here x and dx, so you have negative 1/2 du is equal to x dx. So meaning, the first integral is actually equal to negative 1/2 the integral of e to the u du. And the second term is plus y to the negative 3 dy is equal to the integral of 0. And now integrating, we now have the integral of e to the u du is e to the u. So that is simply e to the negative x squared. So this is negative 1/2 e to the negative x squared. And this, the integral of this is y to the negative 2 over negative 2. So this is negative y to the negative 2 over 2 is equal to c. Okay? And we can further simplify if we multiply both sides of the equation by negative 2 to eliminate this fraction. So you now have e to the negative x squared plus y to the negative 2 is equal to negative 2c. And since negative 2 times a constant is still a constant, then you may use constant c. Okay? So, next problem, the fourth and the last sample problem for separation of variable. Solve the equation 2xy y prime is equal to 1 plus y squared. We are given of initial condition when x is equal to 2 and y is equal to 3. So remember that if we are given of conditions, initial conditions, we are actually asked to give the particular solution. And when we say particular solution, it is actually derived or taken from the general solution by substituting the value of the constant of integration c. And that value of constant of integration c can be obtained when we apply the given conditions. Okay, so let us solve this problem. So you have here two xy, and our y prime again is the derivative of y with respect to x, is equal to 1 plus y squared. Okay? So, multiplying both sides by dx, you have 2xy dy is equal to the quantity 1 plus y squared dx. Okay? And now, how are we going to separate the variables? So, you have here your y dy. So, we do not need here x. And on the right side, since we have dx, then we divide it by 1 plus y squared. So, we are going to divide both sides of the equation by x times 1 plus y squared. And dividing, the resulting equation is 2y over 1 plus y squared dy is equal to dx over x. Okay? And now the variables are separated so we can take the integral of both sides. And here, if you let u to be equal to 1 plus y squared, what is our du? That is equal to 2y dy, which is already our numerator. So the left term or the left side of the equation is actually equal to the integral of du over u, and that is equal to ln of u. And u is 1 plus y squared. So ln of 1 plus y squared is equal to, again, this is the integral of dx over x, so that is ln of x, and we use again plus ln of c. Okay? And then we can apply again property of ln on the right, so this is ln of 1 plus y squared is equal to ln of the product cx. And base e of both sides, then you have 1 plus y squared is equal to cx. And that is our general solution. General solution again because it contains the arbitrary constant. And since we are asked to find when x equals 2 and y is equal to 3, so using our general solution obtained of 1 plus y squared is equal to cx, and applying the conditions when x is equal to 2 and y is equal to 3. So substituting the values of x and y, you have 1 plus 3 squared is equal to 2c. And therefore, finding c is equal to 5. Therefore, our particular solution for this differential equation when x is equal to 2 and y is equal to 3, we just substitute c to our general solution. 1 plus y squared is equal to 5x. Okay? That is now our particular solution. Or if you want, you can express y as a function of x. You can have y squared is equal to 5x minus 1. Okay, so that is my fourth example on separation of variables. And the next video will be another form of differential equation, which is about the homogeneous differential equation. I do hope that you have learned something, that you get something from this discussion of separation of variables. Thank you.